Hello everybody, back again. Let's have a look what we got here today. We have the same principle. This is the LED screen based on 4 bits mode with 6 pins connected to our Arduino Nano. All right, we got a Hall effect, or a magnetic sensor that picks up. It's used as a switch. You can switch electricity on and off, practically, with a magneto. If a magneto gets too close, you can see the percentage increasing. Right, let me do it properly. Okay, so let's have a look. There we are. You can see the percentage is increasing. This would have lit up a bulb or switched off a bulb, or even, like you call it a 3D printer, your cartridge to move forward or move backwards. It does also, is used for mechanical switches. Okay, now let's try the invert the polarity. I'll turn it around, and it doesn't accept the polarity on the other way, except one way. Okay. So as you get closer, the magnetic field goes up to 35, 36%, probably 40%. This is the strength of the magnetic field. Let's try another one. This is a magneto again. There we are. Okay. Now this is it's fun things to use it, and we could program it to, one of the videos that I've got, if you look around, there is a hole with a green or red light. Once it's on, the red light stays on when there is no magnetic field, and when the magnetic field increases, the green light goes on, or vice versa. You can switch a LED on and off, and there's a lot of things. You can move a servo left or right depending on the power of the magnetic field that is around it. See the distance. It's 0 now. When you set it up, you must remember that I'm using 5 volts, so I'm using 1023. But what happened on the code, if you see here, on the code, I had to make a baseline of 521, which is half of 1023. The reason why I had to do this is because without this one, it showed that at the start I was 51. At the start I was 51% of magnetic field already there. So that means that there is a lot of interference, because in front of the computer you might have speakers and so on, or other item that is affecting it. So I brought it down to 0 by cutting it in half with the baseline. And that's why now it's working from 0. It's less confusing. So there you are. And you can see, even at this distance, if you see here, is already picking up 1%. See, there, look at the distance. It's quite. So if you've got a speaker or other magnetic closer, or a strong magnetic, like this one, for example, maybe this looks like stronger, about the same probably. Yeah, it's interesting. In any case, yeah, we are just having fun measuring the magnetic field around this space. Okay, let's go back to the code. All right, so the baseline, which is very important. I've used the LiquidCrystal, and this is the pin numbers that I've used. Okay, the pot, remember on the previous one, it's a VO. It's the pot is on VO, yeah. And the pot is just for the screen, because we don't have the other one on the. Usually you have the pot on there. On the PFC, I think it's called 85774. Yeah. Okay. So back to the code. Yeah, I think we cover just about everything. It's there it is. This is the adjustable value for the and it's 5. It's 1023. The baseline it's 100 and the value. But so yeah, there we are. And you can see if I take the baseline off, it'll go back to 51 at the startup, which we don't want. We want 0, so we can actually check it correctly. All right, guys. Thank you very much. Next is going to be a sound detection bars. Okay. Have a good day, and we'll see you later.